Module Technical Course Internet of Things for Industry 4.0. Lecture 4 Cloud and Wireless Technologies for IoT Application. During this lecture, we will discuss IoT protocols, cloud platforms, and IoT devices. Features of qualitative and quantitative analysis of IoT services, as well as recommended cloud platforms, will be presented. Efficient IoT communications require protocols that enable lightweight, secure, and reliable communications without compromising the computational and energy constraints of the IoT devices in use. There are many of protocols that can be deployed to transfer data at different layers. The OSI model stands for Open Systems Interconnection Model, a conceptualized framework used to describe the 7 layers of a telecommunication system or network. OSI is a protocol stack in the network model, most often considered in the context of IoT systems technologies. This model helps visualize the operation of networks and is used to figure out and solve network issues. In our case, we will talk about the 5 layers of the OSI model and how each of them works. We will discuss the various IoT protocols applied at different layers and analyze the effectiveness and reliability of these protocols based on their energy efficiency, security, and lightweight nature. So, application layer protocols are used to connect smart things as well as end users' personal computers to the internet. Transport layer protocols are typically responsible for point-to-point communication, which means that code is managing, establishing, and closing communication between 2 specific networked devices. Network layer protocols provide network routine and link encapsulation capabilities. The following 5 standard low-power data link layer protocols are used for short-distance wireless communication within the same local area network. At the physical layer, you can see in particular such well-known protocols as Wi-Fi and Bluetooth. On this slide, you can see a typical IP-based IoT protocol stack that is depicted and compared to the classical Internet protocol stack used by standard non-constrained nodes to access the World Wide Web. At the application layer, the HTTP protocol can be replaced by the constrained application protocol, which is a protocol for use by resource-constrained devices, offering a representational state transfer service for machine-to-machine communications that can be easily translated to or from HTTP. There are some other application-level protocols, for example, XMPP for real-time messaging and addressing devices in small networks, and MQTT for collecting data from multiple nodes and sending it to a server. Studies have shown that the MQTT data transfer protocol is suitable for use in IoT systems, as it is able to provide reliable and secure routine for small and cheap devices with low power consumption and low memory levels in unstable networks and networks with low bandwidth. It should be noted that today both wired and wireless technologies are actively used to connect devices in IoT systems. Wired technologies, usually based on the Ethernet data transmission standard, require separate cables for each device, are therefore expensive and difficult to implementation. Wireless technologies are used for data transmission over different distances without the use of wired communications. In places where the use of wires is impossible or impractical. Wireless technologies are easy to use, the cost of wireless devices is constantly decreasing, and at the same time their quality is permanently increasing. However, the issues of wireless connection stability and data transfer efficiency require further study. To create a wireless network, it is advisable to choose a communication protocol that can provide the necessary functions and the reliable operation of predefined types of smart components, such as devices, sensors, actuators, etc. Wi-Fi technology is widely used and popular for various applications today. The ubiquity of Wi-Fi allows to connect different devices and sensors to the internet. There are a lot of different low-cost communication Wi-Fi modules for its implementation. Connected to Wi-Fi is often the obvious choice of many developers, especially considering the prevalence of Wi-Fi in local networks of existing infrastructure, fast data transfer, and the ability to process large amounts of data, which is important when organizing video monitoring. When choosing and implementing protocols, the main problem is the compatibility of the protocols and network topologies. Thus, the next important step is to choose one of the network topologies, point-to-point, start, tree, or mesh, for wireless network development. There are clear recommendations to the usage of certain protocols with certain topologies. It is possible to organize a network using a protocol that is not functionally intended for target topology. But in this case, the security and dependability of the system will be at risk. That is unacceptable. The table shows that only a few protocols allow implementing all the considered network topologies, and Wi-Fi is one of them. Today, the migration of enterprises to cloud computing continues. Cloud service providers are delivering ever-growing improvements in cost saving, stability, security, scalability. Among the most popular platforms are Microsoft Azure, Amazon Web Services, Cloud, Google Cloud, ThingWorx IoT, IBM Watson, and others. The platforms differ from each other in scalability or number of end devices, publicity, functionality, flexibility, etc. Important tasks that can be solved on the basis of cloud platform are the collection, storage, processing, and visualization of big data generated by a large number of devices connected to IoT system. At the same time, the questions of choosing a cloud platform for deploying an IoT service, organizing secure data transfer to the cloud, as well as the efficient processing and reliable storage remain open. Part of the indicated on the slide standard contains data that can be useful in assessing and selecting a cloud platform. There are also 8 draft ISO standards for cloud services. The United States National Institute of Standards and Technology has established the following mandatory characteristics of cloud services: on-demand self-service, broad network access, resource pooling, rapid elasticity, measured service. Thus, the compliance of the cloud platform with the characteristics and quality indicators established by the current international standards is an important factor to consider when evaluating and selecting a cloud platform to deploy an IoT service. The method of comparison and analysis of qualitative and quantitative indicators can be used to determine the metrics of cloud platforms and evaluate of IoT services, as well as the criteria for their selection. 8 components can be recommended as quality metrics when selecting IoT service. They are connectivity and normalization, device management, database, processing and action management, analytics, data visualization, additional tools, and external interfaces. The results of the provided comparative analysis of popular cloud platforms and IoT services functionality are shown in this table. The main quantitative indicators for IoT platforms and services analysis are number of devices that can be connected to the service, number of panels for higher quality data visualization, number and type of databases, number of requests per second, data retention time, data transfer rate, amount of data that can be stored, charge per use depending on the number of connected devices, frequency of recording data in the cloud, and period of use. Knowledge-based filtering, a case-based approach, can be chosen as the basis for developing a recommendation technique for selecting an IoT service. The knowledge base of the recommendation system should contain complete information about IoT services. The first table contains specifications according to the international standards. The second table lists and describes functional components in accordance with IoT experts' evaluation. The third table contains quantitative indicators from IoT services providers. As part of the laboratory works, you will gain experience with several cloud platforms and IoT services. Adafruit AI is a platform designed to display, respond, and interact with IoT project data. It is primarily intended for storing and receiving data. Thingy.io is a cloud-based IoT platform that allows prototyping, scaling, and easy managing connected devices. Blink IoT platform offers a complete set of software that enables to prototype, deploy, and remotely control connected electronic devices at any scale, from small IoT projects to millions of commercial connected products. So, existing IoT services can be used as key tools for the development of IoT applications and services for industrial systems that combine physical objects and the Internet. To select a suitable IoT service, it is necessary to use a set of criteria presented in the proposed recommendation methodology, which saves time and money on finding an IoT service that meets user requirements. The actual direction of further study is an intellectual analysis of big data provided by the IoT services. On the slide, you can see the recommended sources of information. Thank you for your attention.